Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to explain the connection between trigonometric functions of an angle and trigonometric functions of a real number, and also work through an example problem where we'll find the value of all 6 trigonometric functions for a real number on the unit circle. I'll begin by explaining the relationship between trigonometric functions of an angle and trigonometric functions of a real number. Trigonometric functions of an angle relate the angles of a right triangle to the ratios of the sides. In the right triangle that's pictured here, let's let theta be one of our acute angles, and we'll label the sides of our triangle as opposite, adjacent, and the hypotenuse. We now define sine theta as the ratio of the opposite side to the hypotenuse. Cosine theta we define as the ratio of the adjacent side to the hypotenuse. And then tangent theta we define as the ratio of the opposite side to the adjacent side. These may be easier to remember if you remember the initials SOH for sine. Sine is opposite over hypotenuse. CAH for cosine. Cosine is adjacent over hypotenuse. And TOA for tangent. Tangent is opposite over adjacent. Cosecant theta is then defined as 1 over sine theta, which is the hypotenuse over the opposite. Secant theta is defined as 1 over cosine theta, so that's going to be the hypotenuse over the adjacent. And then lastly, cotangent theta is defined as 1 over tangent theta, which will be the adjacent divided by the opposite. To understand how this right triangle relates to trigonometric functions of a real number, we're going to place the right triangle in the coordinate plane with the angle theta in standard position. And we'll do that on our next page. Let's now go over the definition of a trigonometric function of a real number. In our picture, you can see that I've placed our right triangle in the XY coordinate plane. Our angle theta is in standard position, and we'll write that as theta. Our circle is a unit circle, so we can notate our radius as having a length of 1. P of xy is a point that travels along the unit circle and changes as theta changes. Let's denote our point P on our picture as P of x comma y. And that's our point right there. Because our point travels along the unit circle and changes as theta changes, we can write x as our function x of theta, and y we can think of as y is a function of theta. Let's now label the arc length subtended by our angle theta as S up in our picture. The formula for arc length tells us that S is equal to r times theta. Our radius, which we can put in our picture here, is equal to 1. So that means if we substitute r is equal to 1 into our equation for theta, we end up with S is equal to theta. So that tells us as S changes, theta changes. Trigonometric functions of a real number are useful for modeling and understanding periodic and oscillatory behavior. That's behavior that changes in time. S is often replaced with t since the length of the arc, or p of xy, changes in time. So we will write down S is equal to theta, which now is equal to t. This allows us to write x and y as functions of time. So we'll write x is equal to x of t, y is equal to y of t, where t is equal to our angle theta. We can now find trigonometric functions of a real number t. P of xy is a point on the unit circle and can be written as P of x of t, comma y of t, and we'll define t to be our angle, which we had defined earlier to be theta. We'll define x as our adjacent side and y as our opposite side, and our hypotenuse is equal to 1 because we have a unit circle. We can now write cosine t as the adjacent divided by the hypotenuse. And if we look up in our picture, our adjacent side is x and our hypotenuse is 1. So that tells us that cosine t is equal to x. So let's put that over in our box. So x is equal to cosine t. Sine t, if we look back up at our triangle, is equal to the opposite side divided by the hypotenuse, which is equal to y over 1, which is equal to y. So in our box, we can write y is equal to sine t. This is worth memorizing. Our other trigonometric functions can be written like this. We'll write tangent t as sine t over cosine t. We'll write secant t as 1 over cosine t. We'll write cosecant t as 1 over sine t. And we'll write cotangent t as 1 over tangent t. We'll now look at an example where we're given a point on the unit circle and we need to find the value of all 6 trigonometric functions. Given p of t is equal to 2/5, comma, the square root of 21 over 5, is a point on the unit circle determined by a real number t. Find the value of all 6 trigonometric functions of t. Our cosine t is equal to x, which is equal to 2/5, because our point is equal to 2/5 root 21 over 5. Our sine t is equal to y, which is the square root of 21 over 5. Our tangent t is sine t over cosine t, which is y over x. So this is the square root of 21 over 5 divided by 2 over 5. The 5's cancel out, and we're left with the square root of 21 over 2. Our secant t is 1 over cosine t. So we just invert our numbers for cosine, and we have 5 over 2. Cosecant t is 1 over sine t. So we'll invert our numbers for sine t, and we get 5 divided by the square root of 21. And then lastly, our cotangent t is 1 over tangent t. So we'll invert our numbers for tangent t, and we'll get 2 over the square root of 21. In evaluating these types of trigonometric functions, the starting point is to realize that x is equal to cosine t and y is equal to sine t. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.